biomass power plant. Solar module, hydrogen fuel cells. Fuel cells is an chemical energy conversion device. It converts chemical energy of a fuel directly into electrical energy. Unlike ordinary electric cells like batteries, the fuel cells uses outside fuel and therefore can operate indefinitely without consuming itself. Hydrogen fuel cells converts hydrogen and oxygen into water in the presence of catalyst, and in the process it generates electricity. The polymer exchange membrane fuel cells (PEMFC) is one of the most promising fuel cell technologies. This type of fuel cell will probably end up powering cars, buses, and even houses. What to do? Press the switch and observe the fuel cells are used to power the car. Hydrogen tank, fuel cells, fueling station, solar module. Solar module in the Hoffman's electrolysis apparatus. The Hoffman's station in the hydrogen tank hydrogen tank in the fuel cells. Hydrogen fuel cells is channeled through field flow plants to the anode on the side of the fuel cells, while oxygen from the air is channeled to cathode on the other side of the cell. Hydrogen flow field, hydrogen gas, air oxygen, backing layers, oxygen flow fields. Rather no anode platinum catalyst causes the hydrogen to split into positive hydrogen ions, protons, and negatively charged electrons. The polymer exchange membranes (PEM) allows only positively charged ions to pass through it to the cathode. The negatively charged electrons must travel along an external circuit to the cathode, creating electric current. At the cathode, the electrons and positively charged hydrogen ions combine with oxygen to form water, which flows out of the cell. Super. Generation of electricity by geothermal energy. Press the start switch and observe how electricity is generated from geothermal energy. Energy under the ground. In some places on Earth, especially near volcanoes, there are hot rocks quite near the surface. These rocks can heat water that is pumped into the ground reservoir. In geothermal power stations, water is pumped down a pipe into the earth and is heated by hot rocks. Another pipe brings the hot water into the surface, some of which is released as steam. The steam that comes out of the ground at high pressure is used to turn steam turbines to generate electricity. Geothermal energy is clean energy because no fuel is burnt, so there are no harmful pollutants released into the environment. Hot rocks fused by explosive 300 degrees Celsius cold water 4 kilometers. Steam turbine, generator, pump, condenser, cooling tower. Electricity generated. Generator and transmission and supply. Substation. Super. Solar car. Press the switch and observe the solar car moving along the path. Solar car is an electric vehicle powered by solar energy obtaining from the solar panels fixed on the roof of the car. Photovoltaic cells convert light energy directly into electrical energy. Currently, solar cars are not a practical mode of transportation but are primarily demonstration vehicles. solar calculator, solar mobile charger, solar cap, solar panel, solar power, electric current, charge controller, battery system, DC power, inverter, AC power. Solar power is the generation of electricity from sunlight. Electricity is produced using photovoltaic cells that absorb the direct sunlight. Photovoltaic cells, solar panels, convert the sunlight into electricity. The solar power system consists of solar panel, a battery and a charge controller. Solar panels produce a direct current. Power when solar panel is connected to a battery, this power is stored in the battery for later use. The charge controller connected between the solar panel and the battery monitors the battery and prevents the solar panel from overcharging the battery while assuring a complete charge. The solar powered system requires an inverter when the DC power needs to be converted into alternating current AC power to operate appliances. Super. Now the power generation station. Solar photovoltaic pump. Solar water pumping system is a standalone system operating on power generated using solar photovoltaic systems. The power generated by solar cells is used for operating DC centrifugal monoblocks pump set for lifting water from bore, open well or water reservoir for minor irrigation purposes. ನೋಡಿ ಮೋಟ್ರ್ ಪಂಪ್ ಯೂಸ್ ಮಾಡಿ ಇರಿಗೇಷನ್ಗೆಲ್ಲ ಇದು ಮಾಡ್ತಾರೆ ನೋಡಿ. India's first solar powered village, Rampura village in Jhansi is the first solar powered village in India. It is an 8.7 kilowatt power plant installed at a cost of rupees 31.5 lakhs. It provides electricity to all houses in the village. ರಾಂಪುರ ವಿಲೇಜಲ್ಲಿ ಸೋಲಾರ್ ಪವರಿಂದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಜನ್ರೇಟ್ ಮಾಡಿ ಎಲ್ಲ ಫುಲ್ಲು ಸ್ಟ್ರೀಟ್ ಲೈಟ್ಸು ಮನೆಗಳೆಲ್ಲ ಸೋಲಾರಿಂದ ಓಡ್ತಾ ಇರೋದು. ಸೂಪರ್ ಅಲ್ಲ? ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಆ್ಯಂಡ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ನೋಡಿ, ಯಾವ್ದಾರ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಆ್ಯಂಡ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟರ್ ಫ್ರಮ್ ಪವರ್ ಸ್ಟೇಷನ್ಸ್ ಟು ಹೋಮ್. The electricity generated in power station travels across the country along the system of underground cables and overhead wires called grid. Along distance transmission incurs loss of power in the form of heat. Since heat losses depend more on current transmissions, it is done at a low current. When the voltage is increased, the current is lowered, or so less power is lost from long distances power lines. Step up transformers at the power stations increases the voltage of electricity supply and reduces the current. Tall pylons carry the overhead wires for high voltage electricity. From the high voltage power lines, electricity flows to substations where step down transformers reduce the voltage for use by heavy industries. The transformers at another substation reduces the voltage further for use by light industries. The voltage is further reduced by step down transformers and distributed for use by office and houses. ಪವರ್ ಸ್ಟೇಷನು, ಆಫೀಸ್ 230 ವೋಲ್ಟ್ಸ್ ಇದೆ. ಪವರ್ ಸ್ಟೇಷನು, ಇಂಡಸ್ಟ್ರಿ, ಇದು ಬಂದು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರು 11,000 kV 450 ವೋಲ್ಟ್ಸು. 3 ಫೇಸು ಸಬ್ಸ್ಟೇಷನು, ಇಲ್ಲಿಂದ ಪೈಲಾನಿಂದ ತಿರ್ಗಾ ಸಬ್ಸ್ಟೇಷನು, ತಿರ್ಗಾ ಪೈಲಾನಿಂದ ಡಿವೈಡೆಡ್ ಟು ಅದರ್ 2 ಪೈಲಾನ್ಸು, ಆಮೇಲೆ ಅಲ್ಲಿ ಸಬ್ಸ್ಟೇಷನು. ಸೊ ಈ ಥರ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆ್ಯಂಡ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. ಸೂಪರಾ? Air pollution from fossil fuel power station. Pollution issues related to electrical power generation. So, mortality and health damage due to pollution from power plants. Air pollution from fossil fuel power station. Burning fossil fuels for electricity generation is the single greatest source of air pollution. Emissions from coal-fired power plants include sulfur dioxides, mercury, nitrogen oxides, carbon dioxide. Burning coal causes smog, soot, acid rain, global warming, and toxic air emissions. Heated water. Water pollution. Pollution issues related to electric power generation. Electricity generation produce many dangerous pollutants, including nitrogen oxides, sulfur oxides, hydrocarbons, dust, soot, smoke, and other suspended matter. These pollutants can cause serious health problems, including early deaths, asthma attacks, respiratory disease, heart attacks, premature deaths. All of these are among the serious public health problems caused by air pollution from electric power sector. Emissions from coal-fired power stations. Water pollution by power plants. Power plants use water for cooling. The quantity of water required by any fossil fuel-fired power plants is huge, up to 1 billion gallons each day. Power plants use water for cooling. The quality of water required by any fossil fuel fired power plant is used up to 1 billion gallons each day. As this water is discharged back to the river, thermal heat pollution occurs. Heated water kills animals and plants that are accustomed to live in cooler water. Radioactive pollution from nuclear energy. Nuclear power also causes some of the most serious environmental impacts indirectly. While nuclear power plants do not release toxic chemicals like traditional power generation plants, nuclear fuel systems create hazards that may threaten people and the environment now and for generation to come, as well as pose risk of catastrophic accidents. Risk of nuclear power radiation. The principal risk associated with nuclear power arise from health effects of radiation. Persons living near nuclear power plants have danger of being exposed to nuclear radiation compared to other peoples. Radioactive waste. Nuclear power plants produce large amounts of nuclear waste. This waste remains highly radioactive for thousands of years and can cause serious radiation damage to all living things if not disposed safely. Reactor accidents. Many people are concerned about the possibility of major reactor accidents. Such concerns increased after an accident at a nuclear power plant in Soviet Union in 1986. Health effects of power plants. Pollutants, what it is, how it is produced. Health effects, most vulnerable populations. Ozone is a highly corrosive invisible gas. Ozone is formed when nitrogen oxides NOx reacts with other pollutants in the presence of sunlight. rapid shallow breathing, airways irritation, coughing, wheezing, shortness of breath makes asthma worse, may be related to premature birth, cardiac birth defects, low birth weight, and stunt lung growth. Health effects. Most vulnerable populations: children, elderly people with asthma or other respiratory disease, people who exercise outdoors. Sulfur dioxide, SO2. SO2 is highly corrosive, invisible gas. Sulfur occurs naturally in coal. SO2, how it is produced, is formed in the gas. When coal is burnt, SO2 reacts in the air to form sulfuric acid, sulfates, and in combination with nitrogen oxides. Acidic particles. Coughing, wheezing, shortness of breath, nasal congestions, and inflammations makes asthma worse. Sulfur dioxide gas can destabilize heart, becomes low birth weight, increase the risk of infant death. Most vulnerable are children and adults with asthma or other respiratory diseases. Particulate matter, a mixture of small solid particles, soot, a tiny sulfuric acid droplets. Small particles are complex and harmful mixtures of sulfur, nitrogen, carbon, acids, metals, and airborne toxics. What is this pollutant? How it is produced? Directly emitted from coal burning, formed from sulfur dioxide, and nitrogen oxide. In atmosphere. Health effects. TM crosses from the lung into the blood stream, resulting in inflammation of the cardiac system, a root cause of cardiac disease including heart attack and stroke, leading to premature death. PM exposure is also linked to low birth weight, premature birth, chronic airway obstruction, remodeling, and sudden infant death. Nitrogen oxides, NOx, pollutant, a family of chemical compounds including nitrogen oxide and nitrogen dioxides. Nitrogen occurs naturally in coal. Nitrogen oxides is formed when coal is burnt in the atmosphere. It can convert to nitrates and form fine acidic particles, reacts in the present sunlight to form ozone smoke. Nitrogen oxides decrease lung functions and is associated with respiratory diseases in children, converts to ozone and acidic particulate matter particle in the atmosphere. Elderly people, children, people with asthma. Mercury, pollutant, a metal that occurs naturally in the coal. How it is produced? Mercury is released when coal is burnt. Health effects, development effects. If babies are born, mother who ate contaminated fish while pregnant, poor performance on tests of nervous system and learning in adults may affect blood pressure, regulation, heart rate, Most vulnerable population, fetus and children are directly at risk. Pregnant women, children, women of childbearing age need to avoid mercury exposure. Carbon dioxide pollutant. Coal has the highest carbon content of any fossil fuel. How it is produced? Carbon dioxide is formed when coal is burnt. Indirect health effects may be associated with climate change, including the spread of infectious diseases, higher atmospheric ozone level, and increased heat and cold related illnesses. People of color, children, people with asthma. How much you can generate? How to press the start switch? Press any switch. Put on electrical. Observe the temperature of the electrical cable. Press other switch one by one to switch on other electrical appliances. Notice the temperature of the cable increase with additional electrical appliances. The overload alarm beeps to caution of the chance of fire. Extension board, fuse protection, electric power sockets, short circuit and fire. Use circuit breakers in main circuits. Check for wire damage. Ask for certified electrical equipment. சூப்பரா டிப்ஸ் ஒன்று கேள்விப்படுறா அதான் earthworthy, the standard in safety, underwriters laboratories. Earthworthy operating instruction. Micro oven start is connected to the main supply. Two plane plug start. ಯಾವ ಥರ ಶಾಕ್ ಹೊಡಿತಾರೆ. ಇಲ್ಲಿ 2 ಪಿನ್ ಪ್ಲಗ್ ಇದೆ, 3 ಪಿನ್ ಪ್ಲಗ್ ಇಲ್ಲ, ಗ್ರೌಂಡಿಂಗೂ ಇಲ್ಲ. ಗ್ರೌಂಡಿಂಗ್ ಇಲ್ಲ ಅಂದರೆ ಶಾಕ್ ಹೊಡಿಯೋದು ಗ್ಯಾರಂಟಿ. ಅದಕ್ಕೆ ಯಾವತ್ತು ಬಿಲ್ಡಿಂಗ್ಗೆ ಗ್ರೌಂಡಿಂಗ್ ಕೊಡ್ಬೇಕಂತ ಹೇಳೋದು. ಗ್ರೌಂಡಿಂಗ್ ಇಲ್ಲ ಅಂದರೆ ಶಾಕ್ ಹೊಡಿಯೋದು ಗ್ಯಾರಂಟಿ. ಎಲ್ಲ ನೋಟಿಗೆ ಮಾಡಬೇಕು ಬಿಲ್ಡಿಂಗ್ನ. ಓಕೆನಾ? ಸೂಪರಾ? ಅದು ಅರ್ಥಿಂಗ್ ಸೇಫ್ಟಿ ಮೆಜರ್ಸ್. ಅದೇ ಇಲ್ಲಿ ಹೇಳ್ತಾರೆ ಮೈಕ್ರೋವನ್ನು 2 ಪಿನಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದೆ. ಶೀಟರ್ ಪ್ಲಗ್ಗು 3 ಪಿನ್ ಪ್ಲಗ್ ಹಾಕಿಲ್ಲ, ಬಿಲ್ಡಿಂಗ್ ಅರ್ಥಿಂಗ್ ಇಲ್ಲ. ಇವೆಲ್ಲ ನೋಡ್ಕೊಂಡು ನೀವು ಮನೆ ತಗೋಬೇಕು, ನಮ್ಮ ಮನೆ ಕೆಟ್ಟಬೇಕು. ಇದು ಒಂದು ಮೇನ್ ಸರ್ಕ್ಯೂಟ್ ಬ್ರೇಕರು. ಅದರ ಶಾಕ್ ಹೊಡಿಬಾರ್ದು ಅಂದರೆ ಈಗ ಮಿನಿಯೇಚರ್ ಸರ್ಕ್ಯೂಟ್ ಬ್ರೇಕರ್ಸ್ ಹಾಕಬೇಕು. ಅಂದರೆ NCB, ಇಲ್ಲಾಂದರೆ MCCB ಮೋಲ್ಡೆಡ್ ಕೇಸ್ ಸರ್ಕ್ಯೂಟ್ ಬ್ರೇಕರ್ಸು. ಅದು ಬಂದು ಮಿನಿಯೇಚರ್ ಸರ್ಕ್ಯೂಟ್ ಬ್ರೇಕರ್ ಯಾವುದೋ ಒಂದು ಹಾಕಬೇಕು. ಇದು ಅದು ಡಬಲ್ MCB, ಇಲ್ಲ ಅದು MCB ಇಲ್ಲ MCB. ಸೊ your electrical security guard ಎಲ್ಲ security guide. ಸೊ ಇದೆಲ್ಲ 75 ಆ್ಯಮ್ಸು. ಎಷ್ಟು ಆ್ಯಮ್ಸು ಎಳಿತಾರೋ ಅಷ್ಟು ಅದ್ರ ಪ್ರಕಾರ ನೀವು ಇದು MCB ಹಾಕಬೇಕು. ಫ್ಯೂಸ್ ನೋಡಿ, ಹೊರಲೆಸ್ ribbon fuse links, cartridge type with glass tube and wire fuse links, knife blade cartridge type, copper fuse link, ribbon fuse link, plug type with ribbon fuse link, systematic symbols, all fuse, circuit breaker, mechanical switching device with makes and breaks current flow, provides protection against over current, safeguards electrical equipments and prevents hazardous during overload and short circuits conditions. Better replacement for fuse. No need to replace when activated. Can be manually or automatically reset. Fuse links, spring, contact and solder coil. Plug type with ribbon fuse link. Electricity home, what to do? Observe the different electrical appliances and the power consumed by them. Select an appliance by pressing the corresponding switch. Observe what the appliance remains on for 60 seconds. Note the energy consumed by appliance in the energy meter. What is going to on? Electrical energy consumed by different appliance is measured by kilowatt hour meter. As the appliance like rice cooker, electric iron, fan, hair dryer, etc. are switched on, the energy consumed by the particular appliance is shown in the kilowatt hour meter. The amount of electrical energy used by appliance is obtained by multiplying the power consumed by the number of hours. So electricity from the local network first passes through a meter known as a kilowatt meter hour meter. When it enters a household system, the kilowatt hour kWh is a standard measure of electrical energy. 1000 watts makes 1 kilowatts. 1000 watts of power when consumed continuously for 1 hour becomes the kilowatt hour for 1 unit. The meter shows the number of units consumed by working of the various appliances over a period of time. The charges for electricity consumed are computed based on monthly readings of the meter. ನೋಡಿದ್ರಾ ಇವಾಗ ನೋಡಿ 30, 40, 41, 42, 43, 44. ಸೊ ಹಾಗೆ ಹೋಗ್ತಾ ಇರ್ತದೆ, ರೀಡಿಂಗ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇರ್ತದೆ. ಮೈಕ್ರೋವೇವ್ನು 700 ವ್ಯಾಟ್ಸು ಅದು ಮಾತ್ರ ಕೊಡ್ತದೆ ನೋಡಿ. ಹಾಗೆ ನಿಮಿಷ ಅಂದ್ಕೊಂಡ್ರೆ 60 ಸೆಕೆಂಡ್ಸ್ಗೆ 60 ರೀಚ್ ಆಯಿತು. ಸೊ ಅಷ್ಟು ಕ್ರೆಡಿಟ್ ಆಗಿದೆ. Motor, what to do? You can make the motor rotate. There are two large permanent magnets with their north and south poles facing inside of the motor. In the middle is an electromagnet whose polarity can be changed by changing the direction of the charge through it. Use the lever to choose the right combination of polarity of the turning magnet to make it rotate. If the time is right, you make it to spin around. Electric motor is a device which converts electricity into mechanical power. It has rotating parts called rotor and stationary part called stator. The commutator or split ring is fixed to the coil and turns around with it. The brushes are two carbon contacts. They connect the coil to the power supply. The interaction between the magnetic field of the rotor and the stator makes the rotor run. Magnet, coil, commutator, split rings, carbon brushes. Electric motor uses magnetic turning effect on a coil. The poles of the magnet face one another. The coil is free to rotate the poles of the magnet. When a current flows through a coil, one side is pushed up and other side is pushed down. So the coil turns. However, when the coil is vertical, the force can't turn it any further because they are pointing the wrong way. As the coil shoots past the vertical, the commutator changes the current direction. Now the force point the other way, so the coil is pushed around other half turn. Commutator, split rings. Crossbar demonstration of model. Calling subscriber, receiving subscriber, line unit, local feed, group unit, register, group marker, line marker. ನೋಡಿ ಇದೆಲ್ಲ ಟ್ವಿಸ್ಟಿಂಗ್ ಪೇರ್ ಕೇಬಲಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿರೋದು. ಟ್ವಿಸ್ಟಿಂಗ್ ಪೇರ್ ಕೇಬಲಲ್ಲಿ ಎ ಬಿ ಸಿ ಡಿ ಇ ಎಫ್, ಸೊ ಇದೆಲ್ಲ ಟ್ವಿಸ್ಟಿಂಗ್ ಪೇರ್ ಕೇಬಲ್ ಕನೆಕ್ಟರ್ಸು. ಸೊ ಎಲ್ಲ ಪ್ರತಿಯೊಂದಕ್ಕೂ ಒಂದೊಂದು ಲೈನ್ ಇದೆ, ಎಷ್ಟೋ ಕೋಟಿಗಟ್ಟಲೆ ಲೈನ್ ಇದೆ. ಸೊ ಅದು ಡಿ ಸಿ, ಎ ಸಿ, ಆನ್ ಆಫು. ಇಲ್ಲಿ ಕಾಲಿಂಗ್ ಮಾಡ್ತಾರೆ, ಟೆಲಿಫೋನು, ಡೆಮಾನ್ಸ್ಟ್ರೇಷನ್ ಸಿಸ್ಟಮ್ ಡೆಮೋನ್ಸ್ಟ್ರೇಷನ್ ಕ್ರಾಸ್ ಬಾರ್ ಸಿಸ್ಟಮ್ ಡೆಮೋನ್ಸ್ಟ್ರೇಷನ್ ಮಾಡಲ್ಲು. ಇಲ್ಲಿ ಟೆಲಿಫೋನ್ಸು, ಅಲ್ಲಿ ಟೆಲಿಫೋನ್ಸು, ಅಲ್ಲಿ ಕಾಲ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ರಿಸೀವ್ ಮಾಡ್ತಾರೆ. ಅದು ಟಾಕ್ ವಿತ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. Alexander Graham Bell makes the first telephone call from New York to Chicago. Talk with electricity. 1876. Alexander Graham Bell, inventor of the telephone, used electricity to transmit speech for the first time. Bell's first telephone patent was granted on March 7, 1876. 3 days later, he had Watson located in different rooms were about to test the new types of transmitters described in his patent. Watson heard Bell's voice saying, "Mr. Watson, come here. I want you." Bell had upset a battery spilling acid on his clothing. He soon forgot the accident and his excitement over the success of a telephone transmitter. Sound waves from the speaker's voice funneled into a chamber where they vibrated a flat sheet of thin iron. The diaphragm disturbed the magnetic field of a permanent magnet around which was wrapped a current carrying coil connected to external battery. The magnetic field induced varying electrical signals in the circuit, which was completed through connection to earth. Videophone is a telephone with a video screen and is capable of full duplex bi-directional video and audio transmission for communication between people in real time. When you call someone on a video phone, you can see them as well as hear them. The picture is sent as an electric signal along wire, just like the voice on an ordinary phone network. Communicate with electricity, telegraph. During 1830s, the American painter and inventor Samuel F. Morse developed a telegraph that used an electromagnet to record dots and dashes. The languages of the telegraph known as Morse code into a moving strip of paper. In 1844, Samuel Morse used the telegraph key to send the message "What hath good route" on the experimental line between Washington, D.C. and Baltimore, Maryland. The sending operator transmitted messages by using a telegraph key to open and close a circuit. At the receiving end, an electromagnet raised and lowered a pen into a moving strip of paper to record the dots and dashes. The receiving operator visually read the dots and dashes and translated them into English letters. 1000 pairs 0.51 mm paper insulated lead sheathered steel tape armored cable. 1000 pair paper insulated lead sheathered steel tape armored cable. 20 pair 1.4 mm 16 pair 0.9 mm 2 wire 4.4 mm coaxial 1 pair lead sheathed steel armored cable. 20 pair 16 pair. 1000 pair 0.5 mm paper insulated lead sheathed cable. 0.6 mm PVC insulated jumper wire. 20 pair 0.45 square millimeter cable. 250 pair 0.51 mm paper insulated lead sheathed steel tape armored cable. 800 pair 0.51 mm paper insulated lead sheathed steel tape armored cable. 800 pair cable. Morse code A B C D E F G H I J K L M N O P Q R S T U V W X Y Z 1 2 3 4 5 6 7 8 9 0. What to do? Press the Morse key and observe how it works. What is going on? Morse key is a basic enough switch for sending a signal. When pressed, the key completes the circuit, which then sends current down the cable. The key is held down briefly to represent a Morse dot and approximately 3 times longer to represent a Morse dash. ಯಾವ ಥರ ತೋರಿಸ್ತಾರೆ ಇಲ್ಲಿ ಸುಡೋದಲ್ಲಿ ನೋಡಿ. 25.7 degree temperature, humidity 46.3%. Weather major cities of the world: Washington DC ಅಷ್ಟು, ಮಾಸ್ಕೋ ಇಷ್ಟು, ಬೇಜಿಂಗ್ ಇಷ್ಟು, ಟೋಕಿಯೋ ಇಷ್ಟು, ನ್ಯೂ ಡೆಲ್ಲಿ ಇಷ್ಟು, ಪ್ಯಾರಿಸ್ ಇಷ್ಟು, ಕೈರೋ ಇಷ್ಟು, ಕೇಪ್ ಟೌನ್ ಇಷ್ಟು, ಸಿಡ್ನಿ ಇಷ್ಟು, ಬ್ರೆಜಿಲಿಯಾ ಇಷ್ಟು, ವಾಷಿಂಗ್ಟನ್ DC ಇದು. ಕ್ಲೌಡಿ ಥಂಡರ್ಸ್ಟಾರ್ಮ್ಸ್, ಕ್ಲೌಡಿ ಥಂಡರ್ಸ್ಟಾರ್ಮ್ಸ್. ಇದು ಬಂದು ಸನ್ನಿ ಇಂಟರ್ವಲ್ಸು, ಸನ್ಶೈನು. Manual induction, what to do? Hold the torch in your hand and place in it position A. Absorb the glow of lamps, LEDs. Move the torch slowly from position A to position C. Passing through B. Absorb the changes in the glow of the lamps, LEDs. Manual induction. Step up transformer. ನೋಡಿ, ಈ ಕಡೆ 12 volts, ಆ ಕಡೆ 230 volts. ಅದೇ ನೋಡಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್, ಸ್ಟೆಪ್ ಅಪ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್. ಸ್ಟೆಪ್ ಡೌನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರು. ಈಗ 240 volts, ಈ ಕಡೆ 12 volts, 12 volts. Transformers is a device that changes or transforms an alternating potential difference voltages from one value to another of greater or smaller value using the principle of mutual induction. Transformer consists of two coils called primary and secondary windings, which are not connected to one another in any way and are wound on a soft iron core. When alternating potential difference is applied to the primary, the resulting current produces an alternating magnetic flux which links the secondary and induces electromagnetic force in it. The value of this EMF depends on the number of turns on the secondary. If the transformer has more turns on the secondary than the primary, the EMF induced on the secondary will be higher. This is called a step-up transformer. Similar transformer with a less number of turns in the secondary is called a step-down transformer. The induced EMF will be in the ratio of number of turns in the secondary and primary coils. Mutual induction, what to do? Hold the torch in your hand and place it in position A. Observe the glow of the lamp, LEDs. Move the torch slowly from the position A to position C. Passing through B. Observe the changes in the glow of the lamps, LEDs. What is going on? An alternating current is flowing through the large circular coil. This causes an alternating magnetic field in the vicinity of coil. The torch has a second coil whose ends are connected to the lamps, LEDs. At position A and position C, due to the strong alternating magnetic fields, an electromotive force is induced in the second coil and the lamps glow bright. At position B, since the magnetic field is weak, the electromotive force induced is less, which is indicated by the low brightness of the lamp. ಇಲ್ಲಿಂದ ಅಲ್ಲಿಂದ ಇಲ್ಲಿ ಗಂಟ ಉರಿಯುತ್ತೆ. ಇಲ್ಲಿಂದ ಆಚೆ ಬಂದರೆ ಉರಿಯೋಲ್ಲ. ಸೂಪರಾ? What to do? Rotate the handle slowly and notice that as the coil rotates in the magnetic field, the bank of lamps glows. Rotate the handle faster to light up more lamps. What is going on? When the coil is rotated, the magnetic field is cuts through magnetic field lines and voltage is generated. The voltage generated is used to light up the lamps. When the coil is rotated faster, more voltage is generated, which in turn lights up more lamps. Turn the handle towards any part of the visual on the wall. Glowing LED indicates the segment selected. 1950, 2009. ಇಲ್ಲಿ 1950, 2009 ಇದೆ ನೋಡಿ. ಈ ಕಡೆ ತಿರ್ಸಿದ್ರೆ ಏನು ಬರ್ತದೆ 2009 ಆ್ಯಂಡ್ ಬಿಯಾಂಡ್. ಇಲ್ಲಿ 2009 ಆ್ಯಂಡ್ ಬಿಯಾಂಡ್. ಸೂಪರಾ? 1950 to 2009. Nineteen 49. Fluorescent lamp. $1850, 1899. 1850 electric bulb. Thomas Alva Edison. $1800, 1849. 1800, 1849. Electric motor. Michael Farad. 1791, 1867. 1750, 1799. 1750, 1799. Benjamin Franklin. 1706, 1790. 1700, 1749. Leyden jar. 1745. Peter van Mussenberg. $1650, 1699. First electrostatic generator. Otto van Guericke. 1602, 1686. 1600, 1649. 1600, 1649. The term electricity. William Gilbert. 1544, 1603. 600 BC, 1599. 600 BC, 1599. Static electricity, 600 BC. Lodestone, Tales of Milestus, 624, 546 BC. Around 600 BC, Greek philosopher Miltiades noted the amber attracts creatures and other lightweight materials when rubbed with animal fur. It is the first historical reference to static electricity. He also noticed that lodestone magnetic inner can attract iron. 600 BC, 1519 BC. ಯಾವ ಥರ ಜನ್ರೇಟರ್ ಆಗ್ತದೆ ನೋಡಿ ಹೋಲ್ಸು ಅಲ್ಲಿ ಮೋಟ್ರು ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಆಲ್ಮೋಸ್ಟ್ 9 ವೋಲ್ಟ್ಸ್ ಡೈನಮೋದಲ್ಲಿ ತಿರುಗಿಸಿ ಕರೆಂಟ್ ಜನರೇಟ್ ಮಾಡ್ತಾ ಇರೋದು. ಸ್ಪೀಕರು ಇದೆಲ್ಲ ಇದೆ. ಇಲ್ಲಿ ಆನ್ ಮಾಡಿ ಹಲೋ ಹಲೋ ಅಂದರೆ ಸ್ಪೀಕರಲ್ಲಿ ಬರುತ್ತೆ. ಹಲೋ 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 ಅಲ್ಲಿ ಹೋಲ್ಸು ತೋರಿಸ್ತಾರೆ ನೋಡಿ. ಹೋಲ್ಸ್ ಎಷ್ಟು ಬರ್ತಾರೆ ಆಲ್ಮೋಸ್ಟ್ 6, ಅಲ್ಲೂ 6, ಇಲ್ಲಿ 8, ಆಲ್ಮೋಸ್ಟ್ 10, ಅಲ್ಲೂ 10 ನೋಡಿ. ಅಲ್ಲಿ ಫ್ಯಾನ್ ಎಲ್ಲ ತಿಂತಾರೆ ನೋಡಿ. ಡೈನಮೋ ಹೀಟ್ರ್ ಕಾಯಿಲು ನೋಡಿ. ಇದು ಒಂದು ಹೀಟ್ರ್ ಕಾಯಿಲು. ಫಸ್ಟು ಇಲ್ಲಿ ಹೀಟ್ ಆಗುತ್ತೆ, ಆಮೇಲೆ ಹೋಗ್ತಾ ಅಲ್ಲಿ ಹೀಟ್ ಆಗುತ್ತೆ. ಹೀಟ್ರ್ ಕಾಯಿಲ್ ನೋಡಿ ಇಲ್ಲಿ ಹೀಟ್ ಆಗ್ತದೆ. ಹೀಟ್ ಥರ್ಮಾಕಪಲ್ electricity. Heater coil hit. Press the switch and observe how the thermocouple converts the heat energy into electricity, and the heater coil converts electricity back into heat. Electricity back to heat. Photovoltaic cell. Electricity bulb or light. Press the switch and observe how the photovoltaic cell converts light energy into electricity, and electric bulb converts electricity back to light. Bulb converts electricity back to light. Almost 12 volts. Into light. Blue light ಗೊತ್ತಲ್ಲ into light. ನೋಡ್ರಾ ಸೂಪರಾ.
Static electricity, Herbal static electricity,
Hold the pole with your hand. You can feel a mild shock. What is going on? The pole carries an electric current and will give you a mild shock when you touch. Electrical energy is most commonly known as electricity. You cannot see the energy in electricity, but it is deadly. You can experience the power of electricity. Electric shock. An electric shock occurs when a person comes into contact with the electrical energy source. Electrical energy flows through a portion of the body, causing a shock. You do not get injured because the current is very low, in the range of picoamperes. Nuclear debate. Opinions divided. Generation of electricity by nuclear power. Nuclear power plants are fueled by uranium and naturally occurring radioactive elements. Controlled nuclear chain reaction inside the reactor produces large amount of heat, which is used to produce steam. Turbines convert the heat energy to mechanical energy, which is then converted to electricity by generator. Moderator access. Moderator pumps. Uranium nuclear reactor. Pressurizes the nuclear reactor. Operation full. Control rods. Calendria. Primary coolant pump. High pressure turbine. Low pressure turbine. Generator. High pressure turbine, low pressure turbine. ಎಲ್ಲ ನೋಡಿ. ಕಂಡೆನ್ಸರ್ MSR ಯಾವುದು MSR conceptual model of India's first 540 megawatts indigenously designed pressurized heavy water reactor, Nuclear Power Corporation of India Limited, Mumbai. So the start switch to observe how electricity is generated by nuclear power. Flow diagram of Indian pressurized heavy water reactor. Reactor building, steam generator, PST pump, reactivity, mechanisms, main airlock, safety relief valve, atmospheric steam discharge valve, MSVI, SRV, ASCV, ESCV, MSR, LHP, SCPs, condenser, ASDU, atmospheric steam discharge valves, MSIU, main system isolation valves, emergency stop control valves, condenser steam pump valves, feed water control valves, moisture separator reheater, high pressure turbine, low pressure turbine, boiler feed pump, condensate extraction pump, safety relief valve, high pressure heaters, low pressure heaters. ಇದೆಲ್ಲ ಇದೆ ನೋಡಿ. ಇದೆಲ್ಲ ಯಾವುದು ಕನೆಕ್ಟಿವಿಟಿ ಇಲ್ಲ, ಆನ್ ಆಗ್ತಾವ. Nuclear power plant model. The model is miniature and simplified replica of 540 megawatts pressurized heavy water type of reactor, PSWR, in the scale of 1:100. PSWR. Still heavy water type reactor. Generation of electricity. ನೋಡಿ, Coal burned in furnace, thermal power plant. Coal, the steam turbine, condenser, cooling tower, generator. Coal. Evelution of electricity. Order to press a thermal switch and observe how electricity is generated in a coal-fired power station, thermal power station. The thermal power station has furnace where fossil fuels like coal and gas are burnt to heat water and makes heat water and makes steam. The steam drives a turbine attached to a electricity generator. The steam is then cooled down in a cooling tower. The water can then be used over and over again. What to do? Press the start switch and observe how electricity is generated using thermal power. ನೋಡಿ ಥರ್ಮಲ್ ಪವರ್ ಯಾವ ಥರ ಜನ್ರೇಟ್ ಆಗ್ತದೆ. ಟಿ ಜಿ ಹಾಲು, ಕೋಲ್ ಹ್ಯಾಂಡ್ಲಿಂಗು ಸಿಸ್ಟಮು, ಬಾಯ್ಲರ್ ಹೌಸು, ಅಡ್ಮಿನ್ ಬಿಲ್ಡಿಂಗು, ಅಲ್ಲಿಂದ ಜನ್ರೇಟ್ ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ಗೆ ಸಬ್ಸ್ಟೇಷನ್ಗೆ ಹೋಗ್ತದೆ. ಸಬ್ಸ್ಟೇಷನ್ನಿಂದ ಬೇರೆ ಟ್ರಾನ್ಸ್ಮಿಷನ್ಗೆ ಲೈನ್ ಹೋಗ್ತದೆ. ಬರಲ್ಲ coal conveyor, pressure, boiler on, turbine run up. Five generation of computers. Five generation of computers. Five generation of computers. Computers like any other tool have evolved over a period of time. The history of development of computers is referred to by the different generation of computing devices. Each generation of computers is characterized by the major technological development and fundamentally changed the way computers operate, resulting in increasingly a smaller, cheaper and more powerful device. First generation 1940-1956 vacuum tubes. The first generation computers used vacuum tubes for circuitry and magnetic drums or memory, and were huge in size, occupying bigger rooms. They were very expensive and were using a great deal of electricity. They also generated a lot of heat, which was often the cause of malfunctionings. First generation computers relied on mechanical languages, machine languages to perform operations, and they could only solve one problem at a time. Input was based on punched cards and paper tape. Output was displayed on a printout. ENIAC, Electronic Numerical Integrator and Computer. ENIAC, which is completed in 1946, is an example of first generation computers. It weighed in staging 30 tons, contained 18,000 vacuum tubes, 1,500 relays, and consumed around 25,000 watts of power. It was, however, capable of an amazing 1 lakh calculations a second. Second generation 1956-1963 transistors. In the second generation of computers, transistors replaced vacuum tubes. The transistors, which was invented in 1947, did not see widespread use in computers until the late 50s. The transistors was far superior to the vacuum tubes, allowing computers to become smaller, faster, cheaper, more energy efficient, and more reliable than the first generation computers. Though the transistors still generated a great deal of heat, the subject to computer to damage, it was a vast improvement over the vacuum tubes. Second generation computers still relied on punch cards for inputs and printouts for outputs. Second generation computers moved from cryptic binary machine languages to symbolic or assembly languages, which allowed programmers to specify instruction in words. High-level programming languages were also being developed at this time, such as early versions of COBOL and Fortran. These were also the first computers that stored their instructions in their memory, which moved from a magnetic drum to magnetic core technology. An important example of second generation computer is IBM 1401, which is universally accepted through the industry. First transistor model constructed by the John Bradeen, Walter Brattain, and William Shockley at Bell Laboratories in December 1947. Third generation 1964-1971 integrated circuits. The development of integrated circuits was the hallmark of the third generation of computers. Jack Kilby, an engineer with Texas Instruments, developed the integrated circuits IC in 1958. Transistors were miniaturized and placed on silicon chips called semiconductors, which drastically increased the speed and efficiency of computers. Instead of punch cards and printouts, users interacted with the third generation computers through keyboards and monitors, and interfaced with operating system, which allowed the device to run many different applications at one time with central program that monitored the memory. Computers for the first time became accessible to mass audience because they were smaller, cheaper than their predecessors. Fourth generation 1971 present microprocessors. The microprocessors brought the fourth generation of computers as thousands of integrated circuits were built onto a single silicon chip. What in the first generation filled an entire room could now fit in the palm of a hand. The Intel 4004 chip developed in 1971 located all the components of computer from the central processing unit and memory to input-output controls, a single chip. In 1981, IBM introduced its first computers for home users, and 1984 Apple introduced the Macintosh personal computer. Microprocessors also moved out of the realm of desktop computers and into many areas of life as more and more everyday products began to use microprocessors. As these small computers became more powerful, they could be linked together to form networks, which eventually led to the development of Internet. Fourth generation computers also saw the development of GUI, graphic user interface, the mouse, and handheld devices. First IBM PC, 1981. Fifth generation computers, present and beyond. Fifth generation computers are based on artificial intelligence, parallel processing, ultra large scale integrations, ULSI. The main aim of the fifth generation computers is to develop computers that respond to natural language input. Future of computers, quantum computations and molecular and nanotechnologies will radically change the face of computers in years to come. DNA, deoxyribonucleic acid, DNA, deoxyribonucleic acid molecules, DNA molecules, the material our genes are made of have the potential to perform calculations many times faster than the world's most powerful human-built computers. DNA might one day be integrated into computer chips to create as so-called biochip that will push computers even faster. DNA computers will be capable of storing billions of times more data than personal computers. Comparison of different generation of computers. Technology, first generation, second generation, third generation, fourth generation. Computers are classified into different generations based on technology, speed, size, storage, reliability, cost. First generation technology, vacuum tubes. Second generation, transistors. Third generation, integrated circuits. Fourth generation, microprocessors. Speed of operation was measured in milliseconds. Speed of operation was measured in microseconds. Speed of operation was measured in nanoseconds. Speed of operation was measured in picoseconds. Size, they were large in size. Size of computer was slightly reduced due to miniaturization of components. Computers were smaller as smaller components were squeezed into the IC. Size is so small that it can fit into the palm of the hand. Reliability, as the valves generated a lot of heat, there was frequent failure and they were relatively unreliable. More reliable due to the use of transistors. Computers could work non-stop for long hours. Very reliable. Cost, they were very expensive. Overall reduction in cost. System operating cost reduced considerably. Further reduction in cost. Language, machine language, assembly language, high-level language like COBOL, Fortran, COBOL, BASIC, ALGOL, PL2, etc. Many more high-level languages like C++, Java, Visual Basics, etc. Operating system, first generation nil, second generation nil, third generation the concept of operating system was introduced for automatic processing and multi-programming. Different types of operating systems like Unix, Windows 98, Windows XP, Linux. That is for fourth generation. Example, UNIVAC, IBM 1401, CDC 3600, second generation. Third generation, PDP 11, IBM 360. Fourth generation, IBM personal computers, Apple's Macintosh computers. EPABX. So, EPABX and the other EPABX systems. Telephone exchange. Telephone exchange. The Stoger switch. Stoger switch. Stoger switch and the Stoger switch is an early electromechanical telephone switching system invented by Almond Brown Stoger. According to the legend, Almond Stoger was motivated to invent automatic telephone exchange after having difficulties with the local telephone operators. He first conceived his invention in 1888 and patented the automatic telephone exchange in 1891. Selector theory. The selector starts in the home position, and with each impulse, the wiper contacts would progress around the output bank to the next position. Each output would be connected to a different subscriber. Thus, the caller could connect to another subscriber who was connected to that bank without any manual assistance from an operator. The selector starts in the home position, and with each impulse, the wiper contacts would progress around the output bank of the next position. Each output would be connected to a different subscriber. Thus, the caller could connect to any other subscriber who was connected to that bank without any manual assistance from an operator. Stroger telephone exchange. The Stroger exchange displayed here was earlier part of the museum's internal communications systems between various departments. It was capacity for 100 lines, and there are 6 channels, so that at the same time any 6 subscriber could be connected to any other 6 subscribers. This exchange was commissioned in the museum in 1967. Stroger switch. Telephone exchange. Stroger switch. Telephone exchange is digital telephone systems. Telephone lines were originally designed to carry what is known as analog informations, electrical signals that were very up and down with sounds of a person's voice. In digital technology used in computers, data is coded in long strings of ones and zeros, known as a binary code. A digital system transmits the sounds as binary code, and at the receiving end, they use the binary data to recreate the original sounds. Digital telephony was introduced to provide voice services at a lower cost, but was then found to be of greater value to new network services such as ISDN that could use digital facilities to transfer data speedily. Over telephone lines, ISDN integrated service digital network. Telephone systems use digital technologies at every stage from the sender to the receiver. Digital electronic exchange. Electronic exchange use semiconductor switches that allows more rapid connections than their electromechanical predecessors. Some of the services offered to subscribers in electronic exchange are call forwarding, forward incoming calls to another number, conferencing to partake in multiple subscriber call waiting when another caller is trying to make contacts. PBX, private branch exchange systems. First it was private branch exchange system, now it is electronic private branch exchange system. Many companies now access the telephone network through PBX on their own premises. Such systems connect calls made between extensions within the company, offering many or all of the features of an advanced public exchange, as well as connecting outgoing calls to the public network. Incoming calls to a central number can be connected by operator, while key extensions have direct lines that bypasses operator connections. Alcatel Omni PCX Office. Alcatel Omni PCX Office is a communication appliance designed for small to medium sized enterprises with anywhere from 6 to 200 users. This first true e-communications appliance, it delivers internet, voice, data in a single system. At present, Alcatel Omni PCX Office provides internal communication between different sections of the museum. It also takes care of external communication of Musium. The system is operational since 2007. Telephone exchange, digital telephone systems, digital electronic exchange, EBABX, PBX, Alcatel, Omni, PBX, all this generation of computers. Electricity makes it possible for computers to do calculations. The evolution of modern computers can be seen in specific generation of computers. The word generation with respect to the computers refers to technology and materials used for manufacturing them. With each generation of computers, the size of the computers diminished and the speed increased. In the first generation, computers developed during 1940s and 1950s. Vacuum tubes were used, and the basic computing device. Second generation computers developed during late 1950s and early 1960s saw transistors replacing the vacuum tubes. Third generation computers developed during the late 1960s used integrated circuits, while microprocessor was used to fourth generation computers. Artificial intelligence, parallel processing and ultra large scale integrations (ULSI) are the key technologies of fifth generation computers. Transistors in second generation computers. Vacuum tubes in first generation computers. MOSFET semiconductors in third generation computers. First integrated circuit built by Jack Kelby. First microprocessor Intel 4004 chips. Fourth generation computers microprocessor 1971 present. Third generation computers integrated circuits 1964-1971. Second generation computers transistors 1956-1963. First generation computers vacuum tubes 1940-1956. IBM 7330 tape drive unit. Tape drive unit. In the IBM 1401 computer system tape drive units, IBM 7330 were used for mass storage. The spools of tape were vacuum loaded into columns of air. The recording density was 556 bytes per second. IBM 7330 tape drive unit. IBM 1401 CPU unit, central processing unit. Central processing unit. IBM 1401 central processing unit is the first mass produced business digital computer which was fully transistorized. It was affordable by many business worldwide. The CPU was about 1.5 meters high and 1 meter across. IBM 1401 data processing system. IBM 1401 data processing system. IBM 1401 data is a second generation mainframe computer system based on transistor technology. It appeared in the market in 1959. Input was by punch card, output was by printout forms. It had up to 16K of magnetic core memory and up to 6 tape drives for mass storage. They were mainly used in business data processing application. The basic IBM 1401 system had the following units: IBM 1401 central processing unit, IBM 1402 card reader, IBM 1403 printer, IBM 7330 tape drive, IBM card punch unit, IBM 1402 card reader. IBM 1402 card reader. The IBM 1402 card reader was the main input device for IBM 1401 computer system. The punch cards were fed into the card reader. IBM card punch unit. The IBM card punch unit Punch cards were used as input. IBM 1403 printer. The IBM 1401 computer system came with a train printer. IBM 1403, the fanfold paper was fed in from the bottom. Fed in from the bottom. 1403. IBM card punch 1402, 1403 bottom. Oh yeah, 1403. Ada 1403 printer. Ada 1403 printer, card reader, punch card, central processing unit, tape drive. ಇದೆಲ್ಲ ಸೂಪರ್ ಆಗಿದೆಯಲ್ಲ. Rising arc demonstrates the discharge of high voltage electricity between two conductors separated by an air gap. The two terminals are arranged in such a way that the gap increases gradually from the bottom and the arc strikes across the narrowest part of the gap where insulation of the air is broken by applying 25,000 volts across the terminal. The arc is forced upwards by a combination of heating and electromagnetic effects. Thus the arc takes an increasingly longer path until the applied voltage becomes insufficient to maintain the arc. It then reignites at the bottom to start over again. The phenomenon is observed in horn gap arresters to provide temporary earthing to protect electrical equipments from transient high voltages. ನೋಡಿ 25,000 ವೋಲ್ಟ್ಸು ಯಾವ ಥರ ಫ್ಲೈ ಆಗ್ತದೆ ನೋಡಿ. ಈ 25,000 ವೋಲ್ಟ್ಸಿಂದನೇ ನಿಮ್ಮ ಟ್ರೈನ್ ಓಡ್ತಾ ಇರೋದು. ಅದು ಟ್ರೈನ್ ರನ್ಸ್ ವಿತ್ 25,000 ವೋಲ್ಟ್ಸ್. ಲೈಟಿಂಗ್ ಅರೆಸ್ಟರ್ ಬೆಂಜಮಿನ್ ಫ್ರಾಂಕ್ಲಿನ್. Repulsion. Plasma globe, horn gap, ಕಂಡಕ್ಟರ್ಸು ಇನ್ಸುಲೇಟ್ರು ಇದೆಲ್ಲ ನೆನ್ನೆ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಸ್ನೇಹಿತರೆ, ಇಲ್ಲೇ ವೀಡಿಯೋನ ಕೊನೆ ಮಾಡ್ತಾಯಿದ್ದೀನಿ. ಇನ್ನು ಮುಂದೆ ಇನ್ನೊಂದು ಫ್ಲೋರ್ ಇದೆ, ಅದು ಕವರ್ ಮಾಡೋಣ, ಅದಕ್ಕೆ ಹೋಗ್ತಾಯಿದ್ದೀನಿ. ಟಾಟಾ, ಬೈ ಬೈ, ಓಕೆ.